Besides the lotus leaf, can we find this similar property, meaning the superhydrophobicity, in other organisms? Can we? Let's take a look. Pond skater, just like the paperclip challenge, right? I mean, they are denser than the water, but they can, kind of float on top of water surface and they can move around. Guess what? Understanding this lotus effect technology, we can build a replica. This is definitely heavier than the real one because metal, but then we coat the legs of the skate ponder with a hydrophobic materials, then they can do exactly the same thing. That's not it. Today it's raining. You may not necessarily see a butterfly, but next time you look at butterfly, actually the wings of the butterfly, they are super hydrophobic as well. So the water droplets is ready to roll off from the wings so that they don't stick together. It's simple as that. Okay? And this is the nanoscale that we're looking at. If you look at the scale of the butterfly, actually they have this structure, and then they have all this air in between, and then you all have all this stuff in here. And one other thing, okay, this is not related to this. It may look blue in this picture, but if you put enough water, to soak up the wings of the butterfly, it's not going to be blue anymore. The fact that they have all this like nanoscale structure, they interfere with light, and that gives you this beautiful color. But if I, get a bunch of water, try to, really fill up all this nanostructure with water, they're going to turn into like brown color until all the water molecule, evaporate. So they actually change color. The color you're seeing is the interference with light. Okay, so it gives you superhydrophobicity and also the color you're seeing. Okay, so for those who are interested in it, you can go check out some YouTube video. Okay. Last but not least, shark. If you look at, the shark under the SEM, again, a scanning electron microscope, they actually look like this. They have all this, micron nanostructure. And what happens is that it can decrease the drag. You trap all this air bubbles inside in between all this scale. And guess what we use for that? We try to understand this technology, we try to make swimsuit. Okay? Once they invent this technology, I'm not going to name the company, but in 2008 through 2009, in 1 year, 130 swimming world record has been broken because of this particular technology. Okay? Guess what happened afterward? Well, we banned it. Okay, we want to actually look at the human performance instead of just some special wear that, swimsuit that you're wearing and try to beat the world record. We kind of against the science doping in that sense. What other application can we do? I show you a few. Pond skater, that's not much of a technology. The swimwear, you have some particular technology. The butterfly ring doesn't have much, right? So what other technology can we use? Now, this is the tricky part. The technology at the beginning, they have this superhydrophobicity coated paper. So you see water drop just ready to roll off. But on the other one, it doesn't. So it's just like a replica piece of paper. In here, this is the company. They coat that, the brand name on the water surface. You add one little water droplet, everything just spread out because it has been treated with superhydrophobicity coating. Okay, that's not it, right? I mean, what other things can we do? We can talk about timer. What can we do with a timer? So one of them is treated, the other one without. The one that without the treatment, it disappears. You cannot see the display because we know electronic and water, they don't really like each other. Okay. Tissue paper, that's interesting. This is just a regular tissue paper, right? I add some blue dye and it just mush. But the one that treated with the superhydrophobicity one, you can play with that. That's pretty cool, right? Talking about technology. Regular tissue paper, not the regular tissue paper. What else can we do? Let's try something else. It's clean, there's no residue. You also pay attention, there's no residue. It's completely roll off. Ketchup, same thing. It looks like Play-Doh or something. Okay, do not eat it. Okay. Those are mustard. Bread has been treated with the superhydrophobicity material versus the one that without. Cotton ball, right? So we know what happened in terms of cotton and water, right? They just soak up the water and mush. It does not even have a lake of water, not even a drop. Bye. Okay. So now mud test. This is the coolest one. This is the beginning of the video. Bam! Who want to try this next time? Get your uniform in and then just play with that. See, even fabric that has been treated with superhydrophobicity material, now it's fine. And this is pretty much the end of the video. See what happened. So even paint, it cannot stick on it. So I think from the last video, we can recap once again. We can use it as a waterproof materials that have been shown very clearly. Teflon, you know, your long sticky pan that you have, it has a Teflon coating, hydrocarbon treated. So if you add water droplet, you see water beads, okay? You also prevent ice to form. That will come in useful if we live in a really cold weather, okay? You can use that for other like water sport, okay? Now, one thing they haven't shown, and I think is useful, is the last slide, pretty much I want to show you. Do you guys all have an electronic device? Smartphone, laptop, tablet? Do you guys have one? What happened if I drop this in the swimming pool? What happened to my Samsung Galaxy 4? What will happen? It's probably not going to work anymore, right? Electronics and water, they just don't go well together. Then what happened? The video I show you, it may seem like, oh, some company in the US, they have this really cool technology they want to sell you. But actually, we can also install this technology in Hong Kong. I wish the speaker is working. I've been trying to make the speaker to work. If any of you guys can make the speaker to work, that would be awesome. Because this is a really cool video I want to show you. Okay? You never know. Maybe some small observation that you pay attention to, it can lead to a big discovery. So that's the key message that I want all of you guys to learn from today. So once again, thank you very much for your patience.